Welcome to our statistic learning session. Today we'll talk about implicit hypothesis. This is continuation from our conclusion of our parametric hypothesis testing. In this learning, we'll be talking about multivariate parameter called theta, which has a d dimension, and it is associated with the random variable x, which is an IAT that ranges from 1 to n. Now let there be a g function such that it takes a it it takes a key it takes a subset of d, that key parameters, and try to restrict that parameter to a certain value. That's a function of g. Now let's say g be a theta. Now let's say g be a theta here, where it takes, let me let's just g be a theta. Let's g be the function here that takes a parameter theta, and it looks at the last key. It looks at the last key coordinates of the theta, and try to do something about that. That is, that is theta n plus 1 minus theta n plus 1 naught, and by the way, theta d minus theta d naught. And this is a key, last key value of the last. These are last key vectors, last key. Um, these are a last last subset of size k. These are the last k coordinates of the vector. These are the last k coordinates of the vector. Now, if we have this g as a function, we can ask certain questions out of this. We know that theta is of the size d, and let's say if we constrain where k is equal to 2, let's say it produces only two coordinates, last k is equal to 2, and we can ask a certain question out of this, such that if whether the the whatever function the g is it equal to theta 1 is equal to theta 2, that is theta 1 equal to theta 2. We can ask that question, that whether the theta, which is a of d parameter, we can say that whether first two coordinates equal to the whatever the two values, that is produce two coordinates of the g function theta. And also we can other function. Let's say is if the k is equal to 1, and then g will produce, if k is equal to 1, then g theta will produce only one value, or only one vector, only one coordinate. And we can ask question such that whether it is equal to theta 1 minus theta 2. We can ask that kind of questions here. So we can see that this function g theta has many purposes than just asking whether theta is equal to theta naught. This can be used in many ways and many fashions to answer the questions what we like. It can be used to answer some complicated questions from physics, and it can be used to ask many other questions, such as whether the first factor and second factor are of same strength. These are things we can use this function g theta function to answer our curiosity about the data. Hence, let me quickly summarize. what we learned today. We learned about the hypothesis. We concluded today of the about parametric hypothesis testing, and the topic was about theta, which was a multivariate parameter of size d, and the topic of interest was a xid random variable, and we had a function g that took the d dimension and only to the subset of that d dimension of size k, and we could define this function any way we want to, that that was suitable for our purpose. If you wanted to know whether g theta is a theta was equal to theta or not, then we would take the k of certain size and say that whether g theta was equal to 0. And if you want to know whether the first two parameter, the last the la, well the last the if you want to know whether theta 1, if you want to know whether g theta would produce the first two equal to true coordinates, we could do that too. By assigning k is equal to 2, we could do that too. So there are many uses of this, and we saw those uses too. So that's all for today. I will see you next learning session. Thank you so much.